see if we can keep it going. All right, so here we go. Anytime that we are solving for a piece of a triangle, we're going to use SOHCAHTOA, or we're going to use trigonometry, SOHCAHTOA. So look at what you've been given. You've been given a right triangle, that's 10, this is 28 degrees, and you are looking for the hypotenuse. Anytime this happens, anytime you're looking for a piece of a triangle, you are going to use your trigonometry. So let's look at this 28. Which side would this 10 be? Opposite, adjacent, or hypotenuse? Opposite. This is the hypotenuse. Which function, sine, cosine, tangent, SOHCAHTOA, which function should I be thinking about if I'm using the opposite side and the hypotenuse in my problem? Sine. So I'm going to say sine 28, my angle is 28, and I always take the sine of the angle, or the tangent of the angle, whatever, cosine, whatever. So sine 28 equals opposite over hypotenuse. Does that equation make sense to you? Do you see where all those things came from? Sine equals opposite over hypotenuse. Now, we're going to get rid of the fraction. So we'll multiply by x. So we have x sine 28 equals 10. And then we want to get x by itself. We want to know what x equals. So we'll divide by the sine of 28. So 10 divided by sine 28 will be my answer. So I'm going to go to my calculator. I'm going to make sure that I am in degrees. Okay, so go to mode first of all, and make sure degrees is highlighted. Now, people skip this step and they end up missing all the problems because they're in the wrong mode. Make sure, go to mode, top row buttons. Make sure degrees is highlighted. If it's not, get it highlighted. And then just type 10 divided by sine 28. Nothing tricky, nothing hard. 10 divided by sine 28. And I got x to be 21.30. What about you?
Yeah.
You okay with that? Everybody getting 21.3? Alrighty. Let's look at the next one. Same scenario, but be careful. You're not going to use sine on this problem. We don't use sine on every problem. We use sine when we've got opposite and hypotenuse. What do we have here? Well, we have adjacent and hypotenuse, so it's going to be a cosine problem. So cosine 13 equals what? What does cosine 13 equal in that picture? 4 over x. So what do we do next? Don't go to your calculator yet. What do we have to do next? Multiply by x to get rid of the fraction, and then divide by cosine 13. So x equals 4 over cosine 13. So that's, I got 4.105. I don't know, what do you think? Is that what you got? No? Yeah. Yep. Yeah. I didn't give any rounding instructions, so I just want to make sure you're getting this number. We all want to be getting this number. Okay, so now I got my triangle. It looks like this. Okay, so somebody's back there talking, said I got opposite and adjacent, right? Look at the 52. This is the hypotenuse. You don't have it. You have opposite and adjacent. So what function will we use? Tangent. So we'll say tangent 52. We always take the tangent of the angle, or the sine of the angle. So the tangent of 52 equals what? X over 5. How will I solve that? multiply by 5. So x equals 5 tan 52. 5 tan 52. Now I don't need to do anything. I just type in 5 tan 52. I already have x by itself. So 5 tan 52. I got about 6.4. I got 6.3997. Can somebody nod or something if you agree with that? All right, try D and E with your partner. See if you can get the equation set up and then type it in on your calculator. D and E. See if we can get them set up. Get those done and you check them with your neighbor. I'd love to have a volunteer for each one to come up and put it up on the board for us. Okay, I need a volunteer for the second one. All right, Deshani, thank you. Okay, and everybody else is watching carefully to make sure that you got the right answer. All right, I'm going to check. What do you think? Yeah. These match yours? They match mine. Now, isn't it interesting? The pictures look kind of different, but both of them will use cosine. Because for this angle, this is the adjacent side. And for this angle, this is the adjacent side. So we use cosine for both of our problems. Perfect, perfect, perfect. Does anyone have a question about that section? Think we're okay with that? Oh my goodness. Look what's happening next. Eric.
Why is it sometimes x is over 10, but other times 5 is over x?
It is always, it depends where the x is, and then you always set it up if you're using cosine, adjacent over hypotenuse. So if x is the adjacent side, then it's going to be on top because adjacent over hypotenuse. If x is the hypotenuse, it's going to be on the bottom because hypotenuse goes on the bottom. So forget what's x and what's not x. Always set it up adjacent over hypotenuse. Okay? So just depending on where the x is, we'll determine where it goes. All right? Now, look at part 7. This, believe it or not, is exactly the same as these, except instead of me giving you a triangle, I have given you a word problem. So here we go. Let's see if we can figure this out. Every situation will involve a triangle, a right triangle, and we'll be labeling certain things like we were just talking about, and we'll be using our trigonometry. So here we go. A squirrel is sitting in the top of the tree. So here's the tree standing on the ground. Here's your squirrel. So far, so good? He's looking at a nut on the ground. So somewhere out here, there's a nut on the ground, and the squirrel is looking at the nut. There's your triangle. His angle of depression is 23 degrees. Now, what that means is, if the squirrel, here's the squirrel sitting up here on the top of the tree, and he's looking straight ahead. And then he says, oh, I'm going to look at the nut. So he looks down. When he tilts his head, this is his angle of depression. That's 23 degrees. Now, interestingly enough, if there's a worm in the nut looking up at the squirrel, this is called his angle of elevation. This is called the angle of depression. Depression, depress, look down. Elevation, look up. Those two angles will always match. They're always going to be the same. Can somebody remember from geometry why those would be the same? Yes, parallel lines cut by a transversal. We call these alternate interior angles, and they're congruent always. So what I'm saying to you is, they gave me the angle of depression, but it's going to be the same as the angle of elevation. So if I want to mark it down here, I can. Or I can mark it up there. But if I mark it up here, it is not in the triangle. All right, what else do I know? The tree is 52 feet tall, so this is 52. Find the distance from the nut to the base of the tree. So this is X. That picture looks just like the ones you guys came up and did. Now we're going to solve this picture. We're going to find X. So what function do you think I should use? There's my 23. What function? Tangent. And why am I doing tangent? Opposite over adjacent. So Eric is always opposite over adjacent. So I'm going to say tan 23 equals 52 over X. So this time the X goes in the bottom because opposite over adjacent is my setup. All right, how do I solve that? Kelly Berry, you look like you're tired today, sweetie. It's only Tuesday, not allowed to be tired. How do we solve this, Kelly? Multiply the X. So X tan 23 equals 52. And then I'm solving for X. So Ken, what would I do to finish this off?
Do you divide?
You do divide. What do I divide by?
23.
Tan 23. I gotta divide by this whole thing. So X is gonna be 52 over tan 23. So then I go to my calculator. 52 divided by tan 23. Did you get 122.50 feet?
That's a lot of feet.
That's a lot of feet. All right, ready for the next one? All right, this time we got a seagull on top of a lighthouse. So here's my lighthouse, here's my seagull sitting up here on top of the lighthouse. He spots a fish in the water below. So now you got the seagull looking down at the fish. The gull is 87 feet above sea level. So in other words, he's sitting up in the lighthouse 87 feet. He is 230 feet from the fish. Okay, now wait. Where does the 230 go? The seagull is 230 feet from the fish. It's the hypotenuse. Now, before you get confused, do exactly what the problem says. It says the seagull is 230 feet from the fish. Here's the seagull, here's the fish. The distance between my fingers is 230. All right? Now, what am I looking for? Find the angle of depression from the gull to the fish. Technically, that's right here. I'm not going to do that. I'm going to do this one. Remember, the angle of depression and the angle of elevation are always the same. I don't like the angle of depression because it's outside the triangle. So I like to use the angle of elevation. It's the same thing. If the gull looks at the fish or if the fish looks at the gull, their angles are the same. This is interesting. What function do you think I should use? Sine. I don't know my angle though, so I'm going to say sine x equals 87 over 230. Would you agree with that? You may not know what to do with it, but do you agree with that sentence or that equation? Everybody understand why we're using sine? Okay. Now, on your calculator, you have a way of finding angles. That's what you're looking for, is the angle. The button you press on your calculator is this one. Have you seen that button and kind of wondered what in the world you were going to use it for? That button finds an angle. To find angle. We either use that button, the cosine one, or the tangent one, okay? So we press that button, second sine 87 divided by 230, and I got 22.23 degrees. Tell me if you match me.
Yeah.
22.23 degrees. So his angle of depression, his angle of elevation, they're the same thing, and it's 22.23 degrees. Now, as tired as you are, and as badly as you wish I'd just shut up and sit down, I need you really to listen to this. Sometimes we use the regular sine button, or the regular tangent button, or the regular cosine button, and sometimes we use the fancy one. If you know the angle already, if you have an angle already, you use the regular button, okay? You only use the fancy button if you are trying to find the angle. Got it? We only use second sine, second cosine, second tangent if our job is to find an angle. If we already know the angle, we use the regular button. Regular tangent, regular cosine, right? All right, let's try to keep that in mind as we go through. All right, here we are. I'm ready for number C, or letter C. How far is an airplane from the airport? All right, so I'm going to set my picture up. Here's my plane, and here's my airport. Comes a plane. He's coming in toward the airport. He is currently 5,000 feet above the ground. So the airplane's 5,000 feet above the ground. And the angle of depression to the airport is 17 degrees. Now I can put the 17 here. I'm going to put it here. The angle of depression and the angle of elevation are always the same. Now, where does the X go? How far is the plane from the airport?
To the bottom.
Where is the plane? Where is the airport? How far apart are they? Wouldn't that be right here?